Have you ever wondered if you could use AI to tackle real-world problems? Today, we're doing exactly that. We're going to build a flood detection system from the ground up, combining Google's Gemini AI with Next.js and Python. This project is about more than just coding. It's about creating a practical, impactful application that could genuinely help people. Before we write a single line of code, let me show you the finished application. I have it running on my screen right now. This is our flood detection system. The main feature is our AI-powered image analysis. Here, you can upload an image of a landscape, and our system will use Google's Gemini AI to assess the flood risk. Let's try it out. I'm going to upload this image of a residential area near a body of water. I'll click Analyze Image. And just like that, we get our results. You can see the risk level, a detailed description, and a set of recommendations. The AI provides an in-depth analysis of what it's seeing in the image and gives actionable advice. In this video, you'll learn how to set up a modern web development environment, build a sleek and responsive user interface with Next.js and Shard-CN components, develop a robust backend with Python and FastAPI, integrate Google's Gemini AI to perform intelligent image analysis, and finally, deploy your full-stack application to the cloud for free. This is what we're going to build piece by piece. The final application will be fast, powerful, and ready to use. Now that you've seen the end result, let's head back to the code editor and get started. Alright, let's walk through the high-level architecture of our flood detection system. This diagram shows how the front-end, back-end, and external services all work together to provide a seamless user experience. It all starts with the user on the left. The user interacts with our front-end, which is built with Next.js. The main components are the user interface, which includes options for coordinate input and image upload. Depending on the user's choice, the front-end sends different types of data. For coordinate input, it might fetch map data directly from the Google Maps API to display the location. For image analysis, it sends the image to our backend. Our backend, powered by FastAPI and written in Python, acts as the central hub. It receives requests from the front-end and routes them to the appropriate endpoint. We have an endpoint for /API/analyze/coordinates that handles requests from the coordinate input, and another for /API/analyze/image that processes the uploaded images. The backend also uses several key libraries, including Pydantic for data validation and other standard Python packages to handle the requests efficiently. Here's where the magic happens. The backend's request handling component takes the user's request, whether it's an image or coordinates, and packages it up to send to an external service. In this case, that service is Google's Gemini AI. Gemini AI's role is to perform the flood risk analysis. It takes the input data and processes it according to our prompt, generating the insights we need. It then returns the results in a structured format. Gemini's response, which we've labeled as response data, contains all the crucial information: the risk level, a summary of the analysis, and actionable safety recommendations. This structured response is sent back to our backend. The backend then forwards these results back to the frontend. Finally, the frontend's results display component renders this information for the user to see, and it might also update the map integration with new data like risk overlays. And that's the complete journey of a request through our system, from the user's initial click all the way to the final analysis and display. Lovart isn't just another AI art generator. It's an all-in-one creative suite that combines the power of image generation, video production, 3D asset creation, and Photoshop level editing. This is for content creators, marketers, developers, agencies, and even founders who want to create faster and more effectively using AI, all inside an infinite canvas. Let me show you what it can really do. Let's start with image generation. I'll type a prompt: a premium skincare product in a minimalistic marble bathroom with soft natural lighting. Lovart immediately generates a set of high-quality branded images. These aren't random or over-stylized. The lighting, layout, depth, and details actually feel like something you could use on a billboard or e-commerce site. What sets Lovart apart is that it's trained not just on raw visuals, but on design logic. That means it understands symmetry, focal points, and commercial aesthetic. You're not just getting an image, you're getting a polished, design-aware composition. Let's do a quick edit. Here's one of the generated shots. I'll remove the background with a single click. No manual cutouts, no Photoshop needed. Now let's change the product's color from white to rose gold. I just adjust the prompt and Lovart re-renders the scene while keeping the lighting and shadows intact. Need to move or resize something? You can do that too. Lovart blends the edits seamlessly, so everything feels natural and production ready. This alone replaces several steps you'd usually do in complex software like Photoshop or Illustrator, with zero learning curve. Now let's look at the infinite canvas, one of the most powerful features of Lovart. This isn't a static editor, it's a dynamic space where you can place all your designs, assets, drafts, and versions. Zoom in to focus on details or zoom out for a bird's eye view, rearrange visuals, and compare iterations. Think of it like a design sandbox where you can test ideas, explore options, and organize everything visually without clutter. It's incredibly useful for building brand kits, social campaigns, product galleries, or just brainstorming without constraint. In our second example, we are generating a promotional video. With just a simple prompt, Lovart AI creates an impressive video for us, complete with multiple variations to choose from. The results are incredible, super cool, and surprisingly powerful. Now for our third example, we're generating a professional 3D CAD design suitable for real-world projects. Using this prompt, Lovart AI produces a highly detailed 3D model of a modern motorbike. What's even more impressive is that the file is ready for download and can be exported for further use. Achieving this level of precision and output entirely from a prompt is nothing short of amazing. Lovart isn't just for solo creators, it's built for teams. You can share canvases via link, invite collaborators, leave comments or feedback, and export group work in a few clicks. Whether you're part of a remote team, an agency, or working with clients, Lovart gives you one central hub for your creative project. No more juggling files across apps or chasing people for updates. Lovart isn't just another AI image tool, it's a full-stack creative platform. From static images to animated videos, 3D concepts to real design edits, it brings together everything you need to go from idea to execution without switching tools. It's fast, intuitive, and smart enough to understand the design decisions behind your prompts. You can try Lovart now at lovart.ai. No downloads. Just open your browser and start building. I've linked the product brief in the description below for a deeper dive into features. Thanks to Lovart and the team at Superlinear Agency for supporting this video. If you'd like to see a tutorial on how I build an entire content campaign using Lovart from start to finish, let me know in the comments and I'll make it happen. See you in the next one. Tired of spending hours pitching brands or scrolling endlessly to find the right influencers? What used to take days now takes minutes. This is Lessie AI, the smart AI-powered platform that's changing influencer marketing forever. Lessie AI is your all-in-one influencer marketing assistant. Whether you're a brand, a solo marketer, a freelancer, or a full agency, Lessie AI helps you run campaigns faster, more accurately, and at scale. It finds creators that match your brand, writes the outreach, all from one dashboard. As an early invited user, I've been testing it over the past few days. Here's everything you need to know. Who is Lessie AI built for? Brands and marketers. No need to hire a full team. Lessie handles creator discovery, outreach, and management. Agencies and freelancers. Manage multiple client campaigns in one place, prove ROI, and deliver better results with less time. Startups and SMBs. Maximize your limited marketing budget with data-driven influencer campaigns that actually convert. The first standout feature is the AI-powered creator discovery. Instead of manually searching, you enter your ideal traits. For example, audience size, location, niche, or engagement rate. And Lessie AI returns hyper-relevant matches across TikTok, Instagram, and YouTube. You can also just paste your website or campaign brief. Lessie understands your niche and automatically finds creators that align with your brand. I tried this with a sample brand, and in less than 2 minutes, I had over 100 matched influencers. No guesswork, no manual search. Each creator recommendation comes with full AI-generated reasoning. Lessie tells you why a creator fits, analyzing tone, content, performance, and audience alignment. This level of insight is something most tools don't offer. It helps you make confident decisions backed by data, not assumptions. Next is personalized outreach, one of the most time-consuming parts of any campaign. You can review and edit them, but honestly, most are ready to send out of the box. Once you've selected influencers, everything happens in one place. It's perfect if you are running multi-channel or global campaigns. No spreadsheets, no external tools. Just a clean, simple dashboard with everything you need to manage the full influencer lifecycle. Whether you're targeting creators in the US, Africa, Europe, or Asia, Lessie supports global campaigns with region-based filtering. You can easily discover and collaborate with influencers in your target market and scale to thousands of creators if needed. As someone who's constantly working on digital campaigns, this tool is honestly a game changer. During my first session, I was able to discover over 100 influencers, send personalized outreach to 30 of them, track responses, and automate contracts, all within a single hour. What usually takes a team of people over several days, Lessie did in minutes, with zero learning curve. Lessie AI is currently in private beta, and you can get full access for free. Use the invitation code in the description to activate your trial. That includes 1,500 outreach credits and access to all pro features. No credit card required. Influencer marketing is no longer about guesswork or hoping for replies. Lessie AI is about precision, speed, and scale. Whether you're just getting started or managing thousands of dollars in campaign budgets, this is the platform that gives you a real competitive edge. Try Lessie AI today. Use the invitation code below to unlock 1,500 free outreach credits. No credit card needed. First, we are going to set up our project environment. We'll be using Cursor AI as our code editor. Cursor AI is an editor that uses artificial intelligence to help you code faster by understanding your project, suggesting code, and even debugging for you. When you click the download button, it will show the correct option for your operating system. It shows Mac OS here because I'm on a Mac. After installing it, create a new folder and open it with Cursor AI. Next on the list is ShadCN. ShadCN is a collection of reusable user interface components that you can copy and paste directly into your project. It's not a traditional component library that you install as a package. Instead, you get the source code for the components and can customize them as you see fit. We'll be using Next.js, and you can find the link to ShadCN in the description. On the ShadCN website, you'll find the installation command. You can copy this command and paste it into your terminal to start the installation. After pasting the command into the terminal, you'll be asked a few questions and given some options for this project. We'll be using the default options most of the time. For this project, we'll obviously be using Next.js. For the project name, I will type a period because we want to use the current directory as the project name. Wait a moment for everything to be set up. For the next prompt, we'll select neutral. Wait a few more moments. And now everything is done and finished. Let's go over some of the files and directories we get out of the box. Inside the app directory, we have the global CSS file, which contains styles that are applied to your entire application. This is where you can define global styles, fonts, and CSS variables. Next, we have the layout file, which defines the shared user interface for a route and its children. It's a way to wrap multiple pages in the same layout without repeating code. The page file is where you'll write the user interface for a specific route. This is where you'll create the main content for a page. The lib directory contains a utils file. A utility file is a place to store helper functions and small pieces of reusable code that can be used throughout your application. Here is an example of what might be inside the utils file. This c.n function is a common utility in Next.js projects that use Tailwind CSS. It's used to conditionally combine multiple class names, resolving conflicts between them, and ensuring that the final output is a clean and efficient string of Tailwind classes. The CSX library is used for creating a string of class names from various inputs, while twmerge intelligently merges Tailwind classes to prevent conflicts and keep the final class list concise. Next, we have the public directory, where all your images, icons, and other static assets are placed. The .gitignore file is a text file that tells Git which files or directories to ignore in a project. This is useful for keeping sensitive information or large unnecessary files out of your repository. The components.json file is a configuration file used by shardcn to define the components that are available in your project and their styling. The next.config.js.file is where you configure the behavior of your Next.js application, such as adding custom headers, environment variables, or image optimization settings. The package.json file is a manifest file for your project. It contains metadata like the project's name and version, as well as a list of dependencies and scripts that can be run. Finally, the tsconfig file is the configuration file for TypeScript, which defines how the TypeScript compiler should behave when compiling your code. Now, let's go ahead and run this file to see what we've got. We'll run the npm run dev command inside the console. After running this, we can see that our app is running at localhost port 3000. The code you see here is what we get from next.js inside the page file. This is boilerplate code that you get after installing next.js. What we're going to do now is get rid of everything here and start writing our user interface and components from scratch. We're going to create a div, and inside this div, we're going to add a paragraph that says hello world. Now we have a clean and plain hello world showing on the screen. Awesome. Now, let me show you how the completed user interface looks on a different port so we can compare our progress. On localhost 3001, I'll fire up the complete user interface. This is what the finished user interface looks like. When we extend the screen, we can see that we have two grade columns right after the title. Flood detection system. The first grade contains the analysis methods, and the second grade contains the results. Back in code editor, we're going to add a few elements and classes to style this website to look exactly like the finished project. Let's add these styles to the parent div. We'll add a minimum height of screen height and a background color that's a 3-step gradient from slate 50 via blue to indigo. Right after the parent div, we're going to add another div with these class properties. Container, mxauto, px4, py8, and finally max w6xl. We want the maximum width of the div to be 6xl. Inside this div, we're going to create our header. Let's create our header now. We're going to create a div with the class properties text center and mb-8 to add a little bit of margin at the bottom of the header. Then we'll create another child div and another div, which is the first child of the div we just created. Inside here, we're going to import the globe icon from Lucid React. You get Lucid React available after installing shadcn. This globe is going to have a height of 8, a width of 8, and a text color of blue. Let's add these classes to the parent div to give it a circular blue background. P-3, BG-blue-100, rounded-full, and MR-4. Now, we'll add these classes to the parent div to center the whole globe. Flex, item center, justify center, and MB4. And just like that, we have our globe centered. The next item on the list is the header. Let's add that. This is the header I'm talking about in the deployed website. We'll create an H1 element with the content flood detection system. And we'll add these classes. The text should be 3x large. The font should be bold and the color should be slate 900. Right after the last div, we're going to add a paragraph. We'll create the paragraph element, copy the text from the finished site and paste it here. Now we'll add these classes. A text color of slate. And just like that, we've created the header section of our app. So let's create another div for the input section. I already have that here. Now let's add these classes to it. Grid, and we want the columns to be 1. But on large screens and up, we want the columns to be 2. We'll give it a gap of 6 and a margin bottom of 6. Now we need a card for our input selection, the coordinates and the image. We will install the card component from shadcn. On the shadcn platform, we will click on the drop-down and look for the card component. This is what the card component looks like. There's a demo here, and we can see it even better on the hosted site in these sections over here. Let's copy the installation command and paste it inside our terminal. We'll be searching for component names on shadcn and installing them just like this, so get used to it. Now we can use our card component since we have it installed. We'll call the card component and add these classes to it. A large shadow, a border 0, and a background white with a 50% opacity and a backdrop blur. We can see a subtle effect on the screen already. Let's add the content. First, we'll add a card header, which is going to have a card title with these class properties. Flex item center and a gap 2. Then we're going to add a shield icon and the text. Just like what we have on the completed site. Let's add some height and width and change the text color. And we'll add the text analysis methods. We can copy that here and paste it. There we go. We have it showing at localhost port 3000. Cool. Next is the card content. Inside the card content, we're going to need tabs. Let's head over to shadcn and search for tabs and install it. This is what tabs look like. You can click to display content, which makes the user interface clean and intuitive. We have the same thing over here, so this is what we're trying to replicate. Back on the shadcn website, we're going to copy the installation command and paste it into our terminal and install it. So we're going to use tabs. Inside tabs, we're going to have a tab list, which will list all the tabs. Then we'll add a tab trigger, which will trigger or display content based on the selected tab. Inside the tab trigger, we're going to add an icon and the text. So we'll add the map icon and these classes. For the map icon, let's add a height and width. And the text coordinates. we're going to add a value prop and make sure the name matches the text inside the tab trigger. Then we're going to add these classes. Flex, item center, and a gap 2. We'll create another tab trigger copy the props and classes and change the value from coordinates to image. We're going to add an image icon. We have a red wavy line because image is already imported by Next.js. So we're going to import this image as image icon and use it. Let's add the text image analysis, and we have the image analysis text and icon showing in the tab list. Beautiful. When we check the complete website, we can see them displayed over here as well. Next, we're going to add tab content. That also needs the value prop, and we're going to use the coordinates name since we want this tab content to display the coordinate content. We'll add a space on the horizontal axis of 4 and a margin top of 4. Add a div with the class name grid of 2 columns. And a gap of 4 because we'll be rendering input fields. Next, we're going to add a div that will contain the label and inputs. We'll add a class name of space y2. We're going to add a label which we'll be installing from shardcn. We'll go to their website and copy the installation command. And now we'll add the label. The HTML for attribute is going to be latitude, and the text for the label is latitude. Next is the input. Let's go to the shardcn website and grab the input element and install it. After installing it, we are going to use it. We'll call the input element add the type of number, an ID of latitude, and a placeholder called enter latitude. We'll copy and paste this for longitude. We'll just change everything from latitude to longitude. Let's save this and check localhost :3000. We can see the inputs rendered. Let's add a button. We need to go ahead on the shardcn website and look for the button, copy the installation command, and install it. Now we'll add a button like this with the text analyze coordinates. This is how it looks on the finished website. Inside the button, we'll add the mapping icon, with the class name MR-2 and an H-4. We'll increase the width of the button using the W full class. Awesome. And we can see the full effect on the website. The button width is now full, and the tabs are also working perfectly fine. Alright, let's move on to the image analysis section or tab content. First, let's copy the content from the coordinates tab and modify it for image analysis. We'll paste it here. The first thing we'll do is change the value prop from coordinates to image, and then we'll get rid of everything inside the tab content. We're going to create a div with the class name space y-4. Inside that, we'll add another div with these class properties: a border 2, border dashed, border slate 300, rounded end P6, and text center. This will create the container for our image upload area. Inside this div, we'll create an input element. It will have a ref prop, which we'll leave for now. The type will be file, and it will accept all types of images. We'll also add an unchanged placeholder and a class of hidden. We want to hide this input so we can create our own custom image upload button that references it. Let's create the reference state and use it here. We'll declare a constant called file input ref, and use the useRef hook to extend the HTML input element type. We'll need to import useRef along with useState and useEffect from React. We'll be using these later. Next, we'll add a state to hold the image preview. This code creates a state variable named image preview and a function to update it named set image preview. The useState hook from React is used to manage this state. The string part is a TypeScript generic that tells us the image preview state will hold a string value and the initial value is an empty string. This state will be used to store the data URL of the image, which can then be used in the src attribute of an image tag to display a preview of the uploaded image. We also need to add a state for tracking the selected image. Back to our input, we'll add the ref we just created. This reference points to the input element. Even though the input is hidden, we can still use this reference on another element like a button to trigger the upload modal. The onChange prop will have a function placeholder for now, which we'll fill in later. We're getting an error here because we haven't added useClient to the top of the file. This directive tells Next.js that this component runs on the client side, where browser APIs like file uploads are available. Now, when we click on the Image Analysis tab, we can see the bordered container we created. We're going to fill it with content. We'll use a conditional to check if an image preview is available. If it isn't, we'll show the upload content. Otherwise, we'll show the image preview and analysis button. We'll set up a skeleton like this. Inside the no preview section, we'll create a div with a class of space y4. We'll add the image icon, which is our upload icon. We'll also add a paragraph that tells the user to click to upload an image and another that specifies the file types and mass size it can take. Now, let's add a button to open the upload modal. We'll call the button component and add an onClick event that references the image input we created earlier. The code for this is file input ref.current.click. We'll give the button a variant of outline, a size of small, and a text of choose image. We'll also add a camera icon next to the text. Now, when I click on the choose image button, it fires up the upload modal. Awesome. When an image preview is available, what do we want to show? We're about to create that. We'll add a horizontal space x4 and call the image element. The src will be image preview and the alt will be preview. We'll add class properties of max age 48, center it using MX Auto, make it rounded, and add a subtle shadow. Next, we'll add a button to analyze the image. We'll create the button and leave the onClick empty for now. Inside the button, we'll add an image icon. With a class of mr-2 and an h-4. We'll add the text analyze image, and finally make the button W full to give it full width. We have it beautifully rendered here. Now let's make the image preview work. To do this, we need to add a function to the change on event of our image input. The name of the function will be handle image upload. Let's create it now. The function will accept event as an argument, which is a react.change event of the HTML input element type. Inside the function, we'll get the file from event.target.files. We'll get the first element of the file array, which contains information like the file name and size. You can console.log this to see for yourself. We'll then check if the file exists, check its size, and confirm it's actually an image. If these conditions aren't met, we'll show an alert. Let's pause and add the show alert and alert message state. Back to our handle image upload function. If the checks pass, we'll set the selected image. This code first calls set selected image to store the uploaded file in state. Then it creates a new file reader object, which is a browser API used for reading the contents of files. The reader.onload event handler is set to execute a function when the file reading operation is successfully completed. This function takes the event as an argument and sets the image preview state to the result of the read operation, which is a data URL string. Finally, reader.read as data URL file starts the process of reading the file's data and converting it into a base 64 encoded string, which is perfect for displaying an image in the browser. Now we can test the image upload and see the preview. Next on the list is to create a results section for the analysis. When we check the hosted website, we can see the risk assessment section. We'll create a div with the class names shadow LG, border 0, BG white with a 50% opacity, and backdrop blur small. Now, let's update this div to be a card. Next, we'll add a card header, and inside that, a card title. The card title will contain a trending app icon and the text risk assessment. Pause and type this out. Next, let's add the card content. We'll add a div that will show a loading state whenever the results are being processed. This is the code for that. Pause and copy it. We'll be adding the is loading and analysis type states at the top. Over here, we have the use state definitions for is loading and analysis type. The analysis type state has two types, coordinates and image, with coordinates being the default. Back to the card content. We'll add the section for showing the results later, but for now, let's add the map section. Right after this div, we're going to have this code. We basically have the same card and card title, but instead of using the trending app icon, we'll use a globe icon and make the text interactive map. Next, we're going to add the map error and map ref states and import the map icon to get rid of the red wavy underline. We'll start by importing the map icon and adding the map use state. Then we'll add the map error state. We have the map section rendered beautifully on our preview on the right hand side. Next is to add an alert dialog. This dialog will help us show modals in the app. We'll need to install alert dialog from shardcn. Look for it, copy the command and install it. We'll use the components like this. Adding an open prop set to our show alert state. And an onopen change prop set to set show alert. This code block is a component from shardcn's alert dialog library. It defines the content of the alert dialog box. The alert dialog content component acts as the container. Inside it, the alert dialog header holds the title and description of the alert. Alert dialog title is where we define the title of the dialog, in this case, input error. Alert dialog description is where we display the actual error message, which is dynamically passed in through the alert message state variable we defined earlier. Alright, for the backend, we're going to use Python. Make sure you have Python installed and are able to install packages. I've added a link to setting up Python in the description. So let's create a backend folder, and inside it, we'll write our backend logic. We'll be using FastAPI. FastAPI is a modern, high-performance web framework for building APIs with Python 3.7 plus, based on standard Python type hints. It's known for being very fast, easy to code with, and automatically generating interactive API documentation. We'll cd into our backend folder, which stands for change directory, and install FastAPI. I already have it installed, so I won't be doing that. One cool package we'll be using is Pydantic. Pydantic is a Python library for data validation and settings management. It uses Python type hints to define data structures and automatically validates data at runtime, making your code safer and easier to work with. Inside the backend folder, I've added a requirements.txt file. In Python, a requirements.txt file is used to specify the project dependencies and their versions. This makes it easy for other developers to set up the same environment by installing all the listed packages with a single command. In brief, here's what these packages are used for. FastAPI is the main framework for building our API. UVA-Corn is a lightning-fast ASGI server for running our FastAPI application. Python Multipart is a library needed for handling form data and file uploads. Google Generative AI is the official library for interacting with Google's Gemini AI. Python.env is a library for loading environment variables from a .env file. Pydantic is used for data validation and defining our data models. IOFiles is a library for asynchronous file operations, and Pillow is a powerful image processing library used to handle image files. Now, let's head over to the Gemini documentation website. We can learn more about implementing Gemini AI into our app, which we'll discuss in more detail when we start writing the backend code. Let's create a .env file and add our Gemini API key. On the Gemini AI Studio dashboard, you can generate your own key, copy it and paste it inside our env file. Next, we're going to create a main.py file to contain all the logic for the backend of this project. We'll start by importing FastAPI file and upload file from FastAPI. We'll also import QRS, middleware from FastAPI, base model from Pydantic, and other standard Python libraries like UVCorn, OS, Essentio, Datetime, Login, Google.Generative AI, .env, Base64, IO, JSON, RE, and PIL image from Pillow. We're importing these because they are all essential for building a robust and secure API that can handle file uploads, interact with an AI model, and manage different data types and operations. I'll explain what all of these will be used for as we progress. So we're going to load the environment variables using the load.env method. And we'll configure the login using these lines of code. Login.basicconfig level equals login.info. This line sets up the basic configuration for the login system so that any messages at the info level or higher are displayed. Logger equals login.getLoggerName. This line creates a logger instance for the current module, which allows us to add specific login messages throughout our code. Next, we'll initialize our Gemini AI using gni.configure, and we'll pass in our API key using os.getEnv to securely access the Gemini API key from our environment variables. Then we're going to configure FastAPI by defining our app as an instance of FastAPI and providing a few parameters. Title to be Flood Detection API. Description to be Simple Flood Risk Assessment using Gemini AI. And version to be 1.0.0. Next, we are going to configure the course middleware. We'll write app.add middleware and configure it this way. We'll add the course middleware we imported from FastAPI. We'll allow origins from all sources. We could be more selective and add specific endpoints like localhost port 3000, but we'll go with this for now. We'll also add allow credentials, allow methods, and allow headers to allow the necessary requests from our front end. Let's add these two pydantic models, which we won't be using in this specific part of the app, but are a solid foundation for future development. Pause and copy them. Next, let's define our first route. We'll use app.get with a /, and then we'll have async def route. We'll add a comment that says health check endpoint. This endpoint should return a message with the title Flood Detection API is running. A version of 1.0.0, a status of healthy, and a timestamp formatted in ISO format. Let's add an if name equals main block. This will run our app on port 8001 when the file is executed directly. Next, let's create our start.py file. We'll add this piece of code at the top. The first line is a shebang line that tells the system to execute the script using the Python 3 interpreter. The second is a docstring that briefly explains the purpose of the script. We're going to import uvcorn, os.sys. and path from pathlib. Then we'll add this line, sys.path.append str open parenthesis pathfile.parent close parenthesis. This line adds the parent directory of the current script to the Python system path. This is important because it allows Python to find and import modules like main.py from the project's root directory regardless of where the script is executed. And then we'll check if name equals main. If it is, we want to do the following. This block of code is responsible for setting up the host and port for our API. It first tries to get the port from the environment variables. defaulting to 8000 if it's not set. It does the same for the host, defaulting to 0.0.0.0. It then prints out a series of helpful messages to the console, informing the user that the API is starting and providing the URLs for the API documentation. And then we'll add this. This code block starts the UVicon server to run our FastAPI application. It specifies that UVicon should run the app object from the main module. It sets the host and port based on our environment variables, enables reload so the server restarts automatically on code changes, and sets the log level to info to provide useful logs. Now, in the terminal, we're going to clear everything and list the files using the ls command to make sure we're indeed inside the backend directory. Then we'll type the following command, python3start.py. Now it seems we're getting an error. To save ourselves from digging into a rabbit hole to find this error, we're going to copy what we're getting in the console and hit Command +I or Alt+I to open the chat from Cursor AI. Upon pasting, let's hit enter, and Cursor AI is going to fix it for us. The actual error was because we imported pathlib from pathlib instead of path. Awesome. Let's run the command again, python3 start.py. We're still getting errors. Let's repeat the same process. Copy the error code and paste it in the chat for Cursor AI. The issue was with a comma. The AI has fixed it for us, saving us time and stress. Let's run the command again, python3 start.py. And now we have a successful run. So let's open a new tab and test the endpoint we created. By pressing Command and clicking on this link, it opens a new tab for us. On this endpoint, we can see the results we asked the endpoint to return: the message, status, and timestamp. Let's add our API endpoint for image analysis. We'll define an async function called analyzeImage that accepts a file as an argument. First, we'll open a try except block. Inside the try block, we'll log some information using logger.info. Stating that we're analyzing image along with the file's name. We'll validate the file. If the file's content type doesn't start with image, we'll raise an HTTP exception with a status code of 400 and a message stating file must be an image. We'll also check the file size. If it's larger than 10 megabytes, we'll raise another HTTP exception with the same status code, and a message file size must be less than 10 megabytes. Next, we'll read the image data using awaitfile.read. This will read the image into memory. Let's create another try, except block. Inside this try block, we'll create a variable called image and use the PIL image package to convert the image data into a format that Gemini AI can process. We'll then check if the image's mode is not RGB. If it isn't, we'll convert it to RGB using image.convert open parenthesis RGB close parenthesis. If there's an error processing the image, we'll raise an exception. Next is the prompt. This is the heart of this endpoint, as it tells Gemini AI what to do with the image and how we want it analyzed. Pause the video and type this prompt out. The prompt is a detailed set of instructions for the Gemini AI model. It asks the model to perform a flat risk assessment based on an image of a terrain. It specifies 6 key pieces of information to extract: a risk level, a description of the risk, a list of 3 to 5 recommendations, an estimated elevation, an estimated distance from water bodies, and a description of what the AI can identify in the image. Critically, it instructs the AI to format the response as a JSON object with specific field names such as risk level, description, and recommendations. This structured request is essential for ensuring that the API's frontend can easily parse and display the AI's response without having to deal with unstructured text. Next, we'll create another try, except block. Inside this try block, we'll create a variable for the model using the Gemini package. We'll call the generative model method with the model name, which is Gemini-2.0-Flash-XP. The AI's response will be stored in a response variable by calling model.generateContent, passing in the prompt and the image. Then we'll pass the data. The pass Gemini.response function, which we haven't created yet, will be called to process the AI's response. If there's an error with the AI, we'll throw an exception. This code handles a situation where the call to Gemini AI fails. It logs an error message using logger.error with the specific details of the AI error. It then calls a fallback function, generateImageRiskAssessment, to provide a default or simulated assessment. The image analysis field is then updated with a message indicating that the AI analysis was not available. This ensures that the application doesn't crash and can still provide some form of a response to the user, even if the primary AI service is down. And we return this after a successful analysis from the Gemini AI. This code block returns a JSON response to the client. The success true field indicates that the analysis was completed without errors. The parsed data part is a Python syntax that unpacks the key value pairs from the parsed data dictionary and includes them directly in the returned dictionary. This is a concise way to merge dictionaries. The AI analysis field is set to the value of the image analysis field from the parsed data, and a user-friendly message is provided to confirm the successful analysis. Finally, we'll throw this exception if anything unexpected goes wrong. This is a general exception handler that catches any unforeseen errors. It logs the unexpected error using logger.error and then raises an HTTP exception with a 500 status code, which signifies an internal server error. This ensures that any unhandled errors are caught, logged for debugging purposes, and result in a proper error response being sent back to the client. The parse Gemini.response function. Let's scroll all the way up and create the parse.gemini.response function. This function, parse Gemini response, is responsible for taking the AI's raw text output and transforming it into a structured dictionary that our application can use. The code defines the function, specifying that it takes a string, response text, and returns a dictionary. The code is wrapped in a try.except block to handle any parsing errors gracefully. It then uses a regular expression, or RE, to find and extract the JSON object from the AI. As response, as the AI might include extra text around the JSON, if a JSON object is found, it's loaded into a dictionary using JSON.loads. A new dictionary is then created with default values to handle any missing fields. If no JSON is found, the function returns a predefined generic dictionary with default risk information. The except block logs any parsing errors and returns the same generic dictionary, ensuring a stable response even in the event of a failure. And let's define the method to generate a simulated image risk assessment. We'll define a method here called generate image risk assessment that will return a dictionary. We'll add our comment, generate risk assessment for image analysis. Next, we'll import random. We'll create a risk level variable and use random.choice to select one of the following choices: low, medium, high, very high. Then we're going to add descriptions like this. This code block is a dictionary that maps each possible risk level to a corresponding description. This is used in the generate image risk assessment function to provide a descriptive text for the simulated risk assessment. For example, if the random risk level selected is low, the function will use the description image analysis shows low flood risk terrain. Then we'll add our recommendations like this as well. This is another dictionary similar to the descriptions, but it maps each risk level to a list of specific recommendations. This structured data allows the function to provide a set of contextually relevant suggestions for each risk level. For instance, if the risk is medium, the recommendations will include improving drainage infrastructure and considering flood monitoring systems. And then we'll return the risk level, description, recommendations, elevation, and distance from water. In summary, the Analyze Image endpoint is a core part of the application's backend. It acts as an intermediary between the frontend and the Gemini AI model. Its purpose is to receive an image file, validate it for size and type, process it into a format the AI can understand, and then send it to Gemini AI along with a detailed prompt. The prompt is designed to get a structured JSON response. which the API then passes and returns to the front end. This entire process allows the app to perform an AI-powered flood risk analysis on an image uploaded by the user, and to provide a consistent response even if the AI call fails by falling back to a simulated assessment. First, in the page.tsx file, we'll create some interfaces to define the structure of our data. The flood risk data interface will define an object with a risk level of 4 possible types: low, medium, high, and very high. It also includes a description, recommendations, which is an array of strings, elevation, and distance from water. Next, we'll define a variable called API underscore base underscore URL, which will be the URL for our backend, like http colon / localhost colon 8001. Then we'll create a method for calling the API. Pause and copy this code. This is an asynchronous function that handles API requests. The line const response await fetch API underscore base underscore URL endpoint makes an API call to a specific endpoint on our backend. The headers line sets the headers for the request. If the endpoint contains coordinates, it sends a content type header of application /JSON to let the backend know it's receiving JSON data. Otherwise, it sends no headers. The body line sets the body of the request. If the endpoint is for coordinates, it converts the data to a JSON string. For image analysis, it sends the raw file data. The line if response.ok throw new error checks if the response was successful, with a status code between 200 and 299. If not, it throws an error, the line return response.json colon. If the response is successful, it returns the parsed JSON data. Next, we'll create a function called getRiskVariant, which accepts a risk level as an argument. If the risk level is high or very high, it returns a destructive variant. If it's medium, it returns a secondary variant. Otherwise, it returns a default variant. Then we have the getRiskIcon function to choose the correct icon and color for each risk level. This function determines which icon to display based on the risk level string. Risk level equal very high or risk level equal high. This part of the code checks if the risk level is either very high or high. If it is, the code returns the alert triangle icon, which is often used to represent warnings or dangers. The icon is given a specific height and width. Risk level equal medium. If the first condition is false, this condition checks if the risk level is medium. If it is, it returns the info icon, which is used for informational purposes. Else, if neither of the above conditions is met, meaning the risk level is low, the code returns the check circle icon, indicating everything is fine. Let's create a handle image analysis function. This will be an asynchronous function. If no image is selected, we'll set the alert message to please select an image first, set show alert to true, and return. Then we'll set its loading to true. We'll create a try catch block. Inside the try block, we'll create a form data instance. We'll append the file to it so we can send it to the backend using form data append file selected image. We'll create a variable called API response and await the call API function, passing in the endpoint analyze image and the form data. Next, we'll create and define the risk data object. This code block creates a new object, risk data, and explicitly types it as flat risk data. Risk level, API response risk at level. It assigns the risk at level from the API response to the risk level property. Description, API response description. It maps the description from the API response. Recommendations, API response.recommendations. It assigns the recommendations array. Elevation, API response.elevation. It assigns the elevation value. Distance from water, API response.distance from water. It maps the distance from water. This structured mapping ensures that the data from the API, which might have different naming conventions, conforms to our frontend's flood risk data interface. We'll set flood risk to the risk data and set AI analysis with API response.ai analysis or an empty string. Let's create the AI analysis state. Inside the catch block, we'll log the error, set the alert message and set show alert to true. In the finally block, we'll set is loading to false. Now in the card content where we display the results, we're going to add a section to show the results. We'll render this section if flood risk exists and is loading is false. We'll create a div with a class name of space y-4 and inside it, another div with flex, item center, and justify between. Inside this div, we'll create another div with flex, item center, and gap 2. We'll use the get risk icon function, passing in the risk level from the flood risk object and the span that displays the risk level. Let's add a badge to display the risk level. We'll look for it on the ShadCN website and install it. Pause this code and add the badge. Next, we'll add the flood description from the flood risk object. We'll also add this piece of code for the risk elevation and distance from water. Pause and copy this. This code creates a 2-column grid layout for displaying elevation and distance from water. The outer div with class name equals grid, columns equals 2 gap equals 4, sets up a grid with 2 columns and a gap of 4 units between them. The inner div with class name equals p-4bg-slate-50 rounded-lg represents a single card for displaying a metric. It has padding, a light gray background and rounded corners. The line flood risk.elevation meters displays the elevation value from the flood risk object. It's styled with a large bold blue font. The line elevation is the label for the elevation value, styled with a smaller light gray font. The second inner div follows the same pattern for displaying the distance from water. Now we're going to render this section when there are AI analysis results from the backend. We'll use this piece of code to display the AI analysis. This code conditionally renders a section for AI analysis. AI analysis is a conditional rendering statement. The code inside the parentheses will only be rendered if AI analysis has a truthy value. Separator is a component from ShadCN that adds a horizontal line to visually separate the sections. This is a heading for the AI analysis section. This paragraph displays the text from the AI analysis state. The white space prewrap class is important here because it preserves line breaks and spaces from the AI's response, ensuring the text is formatted correctly. And we're going to add this section to display the recommendations. This code block is a section that displays a list of recommendations. H4 is the heading for the recommendation section. The UL creates an unordered list with space between the list items. The flatrisk.recommendations.map iterates through the recommendations array from the flatrisk object. The LI creates a list item for each recommendation. The key prop is essential for React to identify each item uniquely, and this div creates a small blue circular bullet point for each recommendation. Rec. This displays the text of the current recommendation. Finally, we'll add the button to handle the image analysis. This is the button component that triggers the image analysis process. OnClick equals handle image analysis. This calls the handle image analysis function when the button is clicked. Disabled equals is loading or not selected image. This disables the button if the app is currently loading or if no image has been selected yet. Class name wFull, size .lg. These props style the button to be full width and large. Image icon. This displays an image icon to the left of the button text. Is loading is a conditional text display. It shows analyzing if the app is in a loading state and analyze image otherwise, providing clear feedback to the user. Now, fingers crossed, we can test the application. The backend is running. Let's upload an image and see what we get. We get results from the backend displaying a high risk level. Looking at the image, it's indeed a high risk area with a description, elevation, and distance from water. We also have the actual AI analysis with in-depth analysis and recommendations, making the app useful. Let's try a different image and see what we get. And voila, the AI was able to analyze the image, giving us different results based on what is seen in the actual image. We are now going to host the backend of the project. We'll visit render.com. After onboarding, you'll be taken to a page where you'll select web services. On this page, we're going to use a public Git repo. You can search for the repo here, but let's go to my GitHub page, copy the repo's URL, and paste it here. The repo is Flood Analyzer. We'll copy the URL and paste it into Render. For the app name, we leave it as is. We'll also leave everything else unchanged. For the start command, we'll write Python 3 start.py. We'll select the free tier. For the environment variable, we're going to copy the one we created for the Gemini API key and paste it right here. Awesome. Let's click on Deploy Web Service. We'll wait for a while. This might take a while, but I'm not going to cut it out. I'll leave it just like that so you have the feel of what hosting is like. Once it's done, voila, we can copy the URL. Back in our page.tsx file, we'll replace the API underscore BASE underscore URL with the newly copied URL. Next, we'll host the frontend on Vercel. On this page, make sure you've already pushed your code to GitHub. We'll add a new site, which will be our front-end code. We'll search for the repo, import it, and click on the deploy button. We'll let Vercel do its magic. And our app is deployed. We can test it out on the live deployed URL. We'll upload an image, and voila, we get a result from our live hosted backend as well. Congratulations if you've made it this far. You just built an app with the potential to help individuals and save millions of lives. If you found this useful, please like, share, and subscribe to my channel for more content like this. Catch you in the next one.